Hi everybody, sorry I couldn't be here with you today, but I've done the next best thing and I'm here virtually. Hello! So what I'm going to do for you guys today is we are going to start chapter 7, which is on roots and radicals. But before I get started on those, I want to review a couple things with you first. So the first thing I want to talk to you about is exponent rules. Okay, so the big important one that you need to remember, there's basically two that we're going to talk about today. If I have x to the fifth times x to the third, whoops, that's not next, times x to the third, see how these two things are side by side? So when they're side by side, you just add these two exponents. So that would be x to the 8th power. But if I have x to the 5th raised to the 3rd power, now see how this one, raised up high, when you have an exponent raised to an exponent, raised up high, you multiply. So 5 times 3 is x to the 15th. So remember, side by side, you add them up, raised up high, you multiply. And if you can remember that, you'll be really successful in this chapter. So the first thing that we're going to talk about today is roots. Now you guys have already heard of things like square roots. So like the square root of 16 is equal to 4. But today we're going to talk about roots as powers. So would you believe me if I said that the square root of 16, writing it like this, 16 to the 1/2, this is exactly the same thing. Because I'm taking the square root, so I'm raising it to the 1/2 power. So if you take out your calculator and plug this into your calculator, like 16 raised to the 0.5 power, your calculator is going to tell you that that's the same thing as the square root of 16, which is 4. So square root, 1/2 power. What if I want to find the cubed root of 8? Well, I know that 8 is really 2 times 2 times 2. So the cubed root, now remember square roots, these guys are going to come out in pairs. So this pair is 4. And these cube roots, everything comes out in a group of 3. So 1, 2, 3, so this is just going to be 2. Now if I want to write this as a fractional exponent, it's really going to be 8 raised to the 1/3 power because this means I'm doing the cube root. So that 8 to the 1/3 power is the exact same thing as 2. What do you think about that? Now, so if I have, let's say, 4, the 4th root of x, how would you write that as a fractional exponent? Well, I think that's just going to be x to the 1/4 power, right? That makes sense. But what happens if I have a power inside here and a root outside here? So let's take it a step further, and maybe I'm going to have x to the 8th, and I want to find the 4th root of x to the 8th. Well, that means all I have to do is x to the 8th, raise that whole thing to the 1/4 power. Oh my gosh, now look at these two exponents. What do you do with these two exponents? Multiply, raised up high, you multiply. So 8 times 1/4 is 2, so this whole thing is just equal to x squared. So let's try a couple examples. Basically, did you see here, all I really did was I just did 8 divided by 4, and that gave me the 2nd power on x. So that's what you're going to be doing today. So maybe I want to find the cube root of 8x 9y to the 15th. Now the cube root of 8, I know because we just did it over there. So the cube root of 8 is 2. And then what do I do with this power here? 9, well I just divide it by whatever the root is. So 9 divided by 3 is 3, so that's x cubed. And then 15 divided by 3 is 5, so that's just y to the 5th power. That's it. It's not that hard. So let's think about this. Let's try another one. What if I do the square root of 100 x to the 8th times y to the 10th? Okay, now square root, this isn't written right here, but we do know that this is really a 2 because everything comes out in pairs of 2. So the square root of 100 is 10 times 10, so the square root is 10. And then all I have to do is divide these exponents by 2. So that's just going to be x to the 4th, y to the 5th. Someone's outside making fun of me right now. Okay. So does that make sense? Whatever the root is. Now, the one thing that you do have to remember is anytime this is an even root, so 2, 4, 6, 8, we have to ensure that these are always going to be positive. Just in this section, it's really annoying. So in your book, you're going to see answers of the variables in absolute values because they want to make sure that this is always going to be positive. Okay, so let's try another one of those. So I'll do the 4th root. So because this is an even power, I have to remember to do an exponent on it. Absolute value on it. And I'm going to do x to the 12th, y to the 20th, z to the 8th. Okay, so all I do is I take my variables and I divide them. So 12 divided by 4 is 3, so that's x cubed. 20 divided by 4 is 5, so that's y to the 5th. And 8 divided by 4 is 2, so that's z squared. And because this is an even root right here, in the end, all I have to do is remember to just put everything in absolute values. That's it. So the second part of your homework is going to be somewhat review and a little bit new stuff. So it's going to be on adding and subtracting roots. So we already know, like if I have 3 root 5 plus 2 root 5, since these roots are exactly the same on the inside, all I have to do is add the numbers on the outside. So that just means 3 plus 2 is 5, and then the root stays the same. So what if I have 2 times the cubed root of 7 plus 8 times the cubed root of 7? So as long as these roots match exactly, you can combine them. So they're perfect. The cube root and the number inside is 7, so all I have to do is add these numbers on the outside. So 2 plus 8 is 10 times the cubed root of 7. That's it. So the only thing is that when you're adding these, sometimes it can be a little bit frustrating because you look at it and you think you can't do it, but then you really can, or sometimes you can't. So let me show you an example. The book's going to try to trick you. So 3 times the 4th root of 2 plus 4 times the square root, or the square root of 4. So now I can't add these two things, or let's just make this a 2. So it's, even though these numbers on the inside are the same, the roots on the outside are different. So I can't combine these two because they have different roots. So then you would just say, oh, I'm done. That was easy. But let's say I have 3 times the cube root of 24 minus 5 times the cube root of 81. So right now you're looking at this and you're thinking, oh, nope, can't do it because these are the same, so that's good, but the numbers on the inside are not the same, so that's bad. So you have to simplify in this case and see if we can reduce this at all. So remember, things come out of here in groups of 3 because this is a cube root. So I know that 64 is 8 times 3, and 8 is 2 times 2 times 2 times 3. So if I'm cube rooting this, all of these 2's come on the outside as a single 2, and I multiply by the 3 outside. So when I simplify this whole expression, it turns out to be 6 times the cube root of 3. Now let's see if we can do the same thing for 81. So 81 Let's see, that's 9 times 9, which is 3 times 3 times 3 times 3. So again, these 3's, they come out as a singleton. So that 3 is going to come out as an individual, so 3 times 5 times the cube root of what's left inside the 3. So I'm subtracting 15 times the cube root of 3, and now I got the roots to match. So since these two guys are exactly the same, all I have to do is just deal with the coefficients on the outside. So 6 minus 15 is negative 9 times the cube root of 3. Okay, so that's it, you guys. You can get started on your homework and have a great weekend. I'll see you on Monday.